1.
Hi everyone, this is Vartika and me and Shwetha will be presenting on Internet of Things today. So Internet of Things has become a buzzword. By now, I think most of you would have heard the word Internet of Things. But what does it actually mean? So this term was coined in 1999. So actually, if you see, Internet has been all about people. You know, the information that is there on the Internet, whatever is done with the information in the Internet and whoever it is done for is all about people. But time has changed. Nowadays, the Internet has become about the things. How interesting it would be if I take a simple pen in your hand and add the ability to sense and share its data with other things. It sounds interesting, right? So just like your mobile phone is actually smart enough to know where you are. It knows how close it is to your ear. It knows how much is the brightness of the room you are in, and all such things. Okay, so this is actually a part of IoT. The Internet of Things market is going to be huge. It is expected by 2020 there'll be about 6 devices per person, and the market is going to be about $7.1 trillion. Actually, the first IoT machine was a Coke vending machine at the Carnegie Mellon University. So the sensors are actually increasing exponentially. So what exactly is IoT? So a simple definition would be that it is the world where the web and the physical world meet. So a formal definition would be that it is the evolution of mobile, phone, and embedded applications that will be connected to the internet. And what is important is that the data that is received from this mobile, home, and embedded applications, we do something with the data. So for that reason, it is important that it has the computing and the data capabilities to extract meaningful information. So, but why should one care? It is there. It's an emerging technology, fine. But why should a person care about it? So, I think there are two main reasons for this. One, uh, so at an individual level, it helps you in a lot of ways. So, we'll be discussing the use cases later. So, I think it will make more sense then. And at the organization level, there are a lot of companies, VMware, Intel, Cisco, Google, IBM. All these companies are doing a lot in the field of IoT. So I think it is really important that we stay up to date in this technological market. So when you're dealing with Internet of Things, the first, so what I would like to tell is what a thing is actually. So we keep telling things, right? So a thing is actually can be considered as an embedded device that receives and transmits information over the network. So, so the difficult part is actually building these IoT devices, but fortunately, we already have these devices in the market, and so we can just utilize them to do something meaningful out of it. So these embedded devices are actually based on microcontrollers, and they run software on devices with constrained resources. So these embedded devices, any Linux or Android device can also act as an embedded device. But for for dealing with things, it's usually the 8-bit or the 16-bit microcontroller. But fortunately, the cost of 32-bit microcontrollers has really dropped, and they can provide much more capabilities as compared to the 8-bit or the 16-bit microcontroller. So the software that runs on these embedded devices should meet a certain criteria. So one, that it should be scalable. It should be able to accommodate a large range of devices. Secondly, it should be modular to choose only the components we need. Thirdly, a variety of connectivity options should be there, like Ethernet, Bluetooth, Wi-Fi, and these kind of different connectivity options. And also, it should be reliable for safety critical applications. So what is RTOS? So RTOS is real-time operating system. It is a lightweight operating system that is specially developed for these IoT devices. And so we can use Linux, right? It has all these advantages and features. But we don't use it because if you remove all the unnecessary features from Linux that you don't need, it is still very difficult to run it on a 32-bit microprocessor. So this is how a generic IoT architecture looks like. You have the devices. So it can be a mobile phone, your car, your Raspberry Pi, home automated system, anything. And these communicate over the protocols MQTT or HTTP. These protocols have been specially developed for IoT devices. And then the data that is received on these protocols are then processed, and there is analytics done on it. So this data can be actually seen on the web portal. There are dashboards, API management systems where you can actually see this data. And then the event processing is done on the done, and you can do something as a result of it. So this is a very quick example of how an IoT environment would look like. Suppose in most of the organizations, people book conference rooms and actually don't end up using it. So you can install as simple as a motion sensor in a conference room. And then you can have it talk to any board like Raspberry Pi, Galileo, or your Android phone or Arduino, anyone. And these can then communicate over the MQTT or HTTP protocols and communicate the data to the cloud. On the cloud, you can do analytics, and this can be analytics to decide whether actually room is occupied or not based on how often the motion is happening in the room. And this analytics can then be put in a dashboard, which the user can access either from his laptop or from his mobile. So this IoT has been there for quite some time, but what happened suddenly that, if from papers, writing white papers, people have actually started implementing it. So 5 main reasons I would say is first, the set of processors, that is ARM Cortex-M series. So this was actually first released in 2004. It is 32-bit microprocessor, 64 MB flash, and 500 microamp sleep current. But since the sleep current is so high, these devices would actually not last more than a few weeks. But with evolution, these devices now emit only 500 nanoamps instead of the 500 microamps, which means that these processors can last for a couple of years now instead of just a few weeks. Second is the increasing penetration of the Bluetooth Low Energy. So Bluetooth Low Energy is actually very efficient, and about a 30-bit byte packet can be sent once a second, and still the battery would last for a year. Also, the internet IPv6 gave a boom because since every device that is connected to the IoT network would need an IP address, and IPv4 might not be able to suffice the requirement of that large number of IP addresses. Next is the cheaper cloud computing and storage. So this helps in offloading all the resource-intensive operations to the cloud. So like the data analytics or showing it into the dashboard or deciding what you need to do based on the data can all be offloaded to the cloud. And the last one is the rise of sophisticated machine learning tools, because if you just go on taking data from these devices and don't do anything about it, it makes no sense. So it is important that you actually do something with the data. That's where the rise of sophisticated machine learning tools actually contributed to the boom of IoT. So how do the energy and the IoT devices are related? So energy actually matters a lot because 90% of the time the energy is generated from the battery, and hence the size of the battery matters. 2 things dominate the energy cost. One, the energy derived when sleeping, that is the sleep current, and the radioactive communication. Why these IoT devices do not have too much of RAM is because if they have too much of RAM, then the leakage current becomes significant. So when you're trying to build an IoT network, the first thing that you need to identify is how is your thing going to communicate with the rest of the world? The choice will directly affect the hardware requirements and the cost. So it depends on which networking you're going to use. Also, you need to consider which programming language you're going to use. You can actually use C, C++, and Java, Python also, but however, Java, although it provides such high computing capabilities, it's hardly used because the JVM requires a lot of resources which may not be available on these embedded devices. So let us consider a factory as an example case. So a factory will have a large number of sensors which need to communicate too often, and they're spread across. So in such a case, a wireless technology would actually be a good idea because wireless technology is available everywhere and it is cheap. So this is a very good solution, and usually in such cases, the Wi-Fi is what is used to communicate. So since energy is so significant in these cases, it becomes important that the messages are sent in small chunks so that the energy that is consumed is less. This is where the protocol design comes into the picture. So these are the few protocols that have been specially designed for the IoT. First one is the 6LoWPAN, that is IPv6 over low power wireless personal area networks. So this has been actually adopted by companies like Cisco, and this provides encapsulation and header compression. Next one is the CoAP, that is a constrained application protocol. This is especially designed for use in devices that run on battery. It uses UDP, and it is pretty similar to TCP. After that, the MQTT, that is MQ telemetry transport, it is actually a publish subscribe telemetry transport protocol. So what happens here is, so if there is a server and if the client wants to send some data to it, it is initially going to say publish, and in the bracket it is going to tell what kind of data it is going to send. So it can say publish temperature. That means the server knows that this particular client is going to send me temperature data. Otherwise, if a client wants to read the data from the server, he can say subscribe and temperature. So that means that this particular client is going to read the data from the server. So how is cloud important? As I mentioned earlier, cloud is really important because it helps in offloading the storage and compute capabilities to reduce the complexity at the Internet of Things level. So it is actually expected with 6 devices per person by 2020, there is going to be about 5,200 GB of data per person, which is really huge. And this only implies that we need a very highly enhanced data analytics. So cloud computing, the advantage is that the cloud has immediate access to structured information and unstructured information like databases. So it is always advisable to put this data intensive and resource intensive operations to the cloud instead of the IoT device itself. So what happens in an IoT network is, suppose you have your fridge, car or toaster connected to the IoT network in the gateway, and it is talking to the cloud. So the network that involves your device like the fridge or the car and the gateway is a tightly coupled network. So how often are you going to change your fridge or car? Not really often, right? So whatever evolution usually happens, it happens between the gateway and the cloud. It is the WAN where the evolution actually happens. So the protocol enhancement or the security that happens, it happens in the gateway to the cloud environment, because you do not tend to change your devices very often. So this is one of the boards which is often used for developing coding programs for IoT devices. It's an offering by Intel. It's called Intel Galileo, and this is how the board looks like. So Shwetha will be covering the use cases.
Thanks, Vartika. Yeah, so let us discuss some of the important use cases of IoT. To start with, how to have a smart city. This is basically making the thing smarter. So we have a concept of smart metering. What does the smart metering actually do? So if you look at the industrial level of power consumptions and other areas, right, there will be a lot of power consumption, and it is very difficult for someone to go and monitor them, power on or power off, and you'll not be able to know like what is the actual power consumption, what is the cost of that and all. So through this smart metering, you'll be able to manage the entire power consumption, that is powering on and off of different machines, tools, etc. As well as you will get to know like how much power it is consuming, what would be the cost of it. Next is the smart bottle cap. The smart bottle cap concept, this can be used in the areas like, basically it has two uses. First one is in the restaurants especially, where this can be used for preparing a mocktail or a cocktail without any manual intervention. So how does this actually work? This will work as like the recipes will be already fed into the system. So it will go and see whenever a customer orders a mocktail or a cocktail, it will look into the recipe and it will release only that quantity of ingredient, whatever is required for the specific recipe. The second use case of the smart bottle cap is for health monitoring. So based on the amount of exercise that a person has done, this bottle cap will release the drink for that person. So this will help people to do more of exercise so that they can have more drink. Rock gold is one of another example. Actually, what happens is like in many countries, all these metros, the subways, basically, they will be only through the tunnels. So because as it is like underground, so we will have to drill different areas, right? In that case, you will not know what type of soil you are drilling, and you'll not be able to estimate what would be the approximate time that is required for drilling. Through this rock bolt option, what happens is it will use the accelerometer to check the vibration. Based on the vibration, you will get the data which can be stored, and next time when you are doing a drilling in another area, you will get to know like what sort of area that you are gonna drill, and helps in knowing approximate time that is required. A traffic control system, it is one of the very good example. Say what happens is if an ambulance is arriving, to avoid the traffic jams, especially in countries like India, it is very few, like we always have lots of traffic jam, right? So what happens is like the ambulance itself will not be able to reach the hospital in time. So when we try to use the concept of IoT in the traffic control system, till the ambulance reaches the hospital, the entire stretch will be made as green, so that there will be free flow of traffic, and the ambulance will not have stuck into any of the traffic jams. Yeah, so next.
We heard about what is Internet of Things and a lot of use cases, but how does security come into picture when we are talking about Internet of Things? So one thing is, a study had been carried out and the results showed that the insecure updates can be pushed to more than 90% of the devices. So what does it actually mean? So it means that I can write a software update and I can push it to the devices. No one is going to stop me to do that, and I could ensure that these devices stop providing any sort of confidentiality and integrity. Once that is done, I could manipulate the devices and the data from these devices in any possible way. So it is important that these devices are made secure, and the data from these devices is also made secure. So this particular field of IoT, that is IoT and security, there is tons of money in this particular field, but it is extremely difficult, and hence it has not been explored enough. But why is securing these devices really hard? So the problem is that the IoT devices are heterogeneous in nature. The devices are heterogeneous, the network is heterogeneous. So when a person talks about Internet of Things, his definition of Internet of Things may be extremely different. And since there is a lot of heterogeneity involved, it is very uncertain that if one solution is going to work for all of it. So there are different kind of requirements for these devices. There are different kind of things. There are different kind of technologies involved. There are different kinds of marketplaces. The resources for these devices differ by 6 orders of magnitude. Like your embedded device will have few KB of RAM, but whereas the cloud has exabytes of RAM. So the amount of resources with these devices is different, and developing a common solution for all which can actually support all this heterogeneity is very difficult, and that's why it's a complicated thing to look into. So in fact, these devices might run different kinds of OS, like your gateway or the cloud can have a different OS running on it. So building an application means taking care of all of this. So that's why security is hard in the Internet of Things. But the good thing is that everything that we talked about can be actually split into 3 major domains. One is the industrial automation. So when we say industrial automation, that means doing something at the industry level. So the advantage there is that all the communication that happens, it is usually licensed, and there will be about thousands of devices per person, but the reliability is high because everything is licensed. So in such an environment, usually wireless HART is the protocol that is used. In the home area network, thing is, it is uncontrolled. People can try to do anything at their home. They can experiment in any possible way, and hardly anything is going to be licensed. So the challenge with the home area networks is that it is not licensed, and the experimentation can go to any level. But in these cases, the protocol that is used is 6-LoWPAN. And the personal area networks is the very limited network, like that is used with your Fitbit, or something that is specific to only you. So for the in those cases, the Bluetooth Low Energy and 3G are the protocols that are usually used. So this is how the heterogeneity is handled. The best thing is that there is a common underlying architecture. So these embedded devices, that is the Fitbits or your bulbs, they talk over some low power wireless protocol, like maybe your 6LoWPAN. And then these communicate with the gateway devices. So your phone or your home controller can be the gateway device. And then they provide a bridge to the cloud over the internet using your TCP or UDP. So, and then from the cloud is where the analytics done, and which is presented to the user in the UI. So this is how there is a common underlying architecture, and exploiting this common architecture can actually help in developing a common solution for security for all these range of devices. Shwetha will be explaining the security aspect in further detail.
Yeah, so we know now we are in a position where we understand different use cases of IoT. Why is it important? How can we make the thing smarter? But as the number of devices increases, the data that is gathering is also increasing. And what about the security? Why is it important, right? So as more devices are connected, the number of data that are sent or received over the network will be more prone to the hackers, right? So it is important to secure the confidentiality and integrity of data. So we are trying to provide through two of the aspects, that is a feasibility of HTTPS enabled communication between the device and the cloud, so that we are not using any intermediary devices in between. The second thing is the conceptual principle of Bitcoin blockchain ledger and decentralizing the IoT network using the transactions. This is how actually the HTTPS works. So how it actually works in case of IoT is like the client sends a request to the server saying that I would like to communicate. Then the server says that it is better to use HTTPS, not the HTTP. Then the client agrees, and client responds to the server with a security parameter that it can start communicating with the server. The server compares the security parameter that it has, and then what it does is like it will say like it both will come to a common communication channel saying that okay, they'll agree upon a common parameter. That is the process of the HTTP handshake. Basically, as I told, like two phases. The first one is the handshake process. The second is the communication. So during communication, server sends the digital certificate to the client. Client agrees to trust the server because now they both have shared the common channel. Then client generates a session key using PBKDF2. Why have we tried using PBKDF2? I'll be explaining later. Then client encrypts the session key with the server's public key using RSA. Then client sends the encrypted key to the server. Hereafter, the send and receive of the data happens from both the server and the client aspect. We have done a POC on how the things are working. This is the basic configuration of different boards that we have tried: Arduino Uno, ESP, and Intel Edison. So Arduino Uno, as you can see, like it is having very minimal resources like 2 KB RAM, 32 KB of flash memory, and 16 megahertz of CPU. And ESP, as you can see, it's 64 KB RAM and about 4 MB of flash memory and 80 hertz. And Intel Edison is having a sufficiently good resource. So when we try to do a POC using different algorithms on different boards, what it was amazing to see, like even with the smallest boards that we had, which had very minimal resources, we were able to encrypt and decrypt the data. So we have tried AES CBC, AES ECB, and XXTA algorithms. And the boards are Intel Edison, ESP8266, and Arduino. Now you may be wondering, though the XXTA is a very simple algorithm, why is it consuming so much of time? Here the thing is like when we try to use the code for AES, both the algorithms of AES, we have optimized the code to an extent where you see that a result of optimization, whereas the XXTA code was not optimized to that extent. And whatever you are seeing in terms of time is in terms of the millisecond. Yeah, I told like we are using PPKDF2 for the key generation. You can see here, it is taking about 1.19 second on a ESP12, and on a i5 8GB laptop, it is taking less than 0.1 second. So why is it important? Why is it taking so much of time, and won't it affect the performance? This may be your next question. Though it is having this much of, though it is consuming 1 second on a ESP12, still we are using PPKDF2 because this is the one-time key generation, and it should not matter because even it is taking 1 second for the initial communication, it is more secure. Hackers have very minimal chances of hacking PPKDF2 when compared to other algorithms. Hence, we have preferred PPKDF2 over other algorithms for key generation. Yeah, so we are done with our presentation and open for questions.
Hi, does anyone have any questions that they would like to ask? Either you can use the chat window, or I can unmute you, or you can unmute yourself and you can ask any questions that you'd like. That was a very thorough presentation. I think you both did a very nice job.
Thank you.
Thank you.
So if no one has any questions, I'll go ahead and close it, but I'll put this video up online, and you can always contact us if you have any questions as you watch the video. And thank you again for presenting at Voices. We really appreciate all of your passion in this area.
Thank you.
Thank you.
All right, we'll see you at the next session.
See you.
Bye.